again, and welcome to another fun-filled video in algebra with Mr. Sims. This is solving linear equations 1, also known as solving for a single simple variable, or that's not the technical term, and don't please hold me to that. But basically, it's something you've been doing for a very long time, where you're just trying to solve for a single variable. That variable is not squared. That variable doesn't have crazy other variables attached to it. Basically, it's just solving for one thing that you can find out. So in this case here, you've been doing this since you started school, when you had like question mark plus 3 equals 4. So in other words, maybe you had 3 cookies. You're like, how many more cookies do I need to get to 4? And the answer then is you would need, you would need 1. You would need 1 more cookie. 1 more cookie would get you there. 1 plus the 3 is going to equal 4. And so you solved for this. You didn't know it at the time, but that question mark is acting like a variable. Here's another way you might have seen it when you were young. You had something divided by 3 is equal to 9. You're like, well, if it's got to equal 9 and I'm being divided by 3, you think about, well, what when divided by 3 equals 9? And that answer ends up being 27. 27 divided by 3 equals 9, and you get that because 3 times 9 obviously is 27, and so you're like, oh, okay, well, I have to do the opposite kind of to find it. I would do 3 times 9, right? Kind of undoing it, and you did this without really even thinking about it, perhaps. And in this case here, maybe you had like, there's 20 fish and there's some cats, right? Each cat gets 1 fish, right? And there's 20 fish and each cat gets 1 fish, and there's 5 fish left over after the cats descend upon them. How many cats were there? And so you figured out, well, if each cat gets 1 fish, there must have been 15 cats, right? 20 minus 15 is equal to 5. And another example might have been this: x plus 4 is equal to 7. So this is how you might see it today, right? Where we actually put a variable, we like to put a letter in there for it, so that variable now is x, and that's saying that x plus 4 equals 7. What am I doing? Rewriting it again. I don't need to do that. And I'm trying to say what plus 4 would equal 7. In this case, you could just tell me, well, 3 plus 4 equals 7. And so what I just wanted you to see is you've been actually doing this at a basic level for a really long time, probably earlier than you can even remember. But now we're going to get very systematic at it. We're going to try and help you to get a good system for solving just whatever it gets thrown at you, right? So let's go ahead and jump right in. Make sure as you're doing this, make sure that you have a paper and pencil handy, that you are doing it, because if you're not doing it, I got to be honest, you're kind of wasting your time, because you're not actually going to pick it up. Like, you need to actually do the practice. You need to try it. Whenever I give you a problem, I want you to pause it, try and solve it. If you're successful at solving it, then you're good. If you're not, well, then maybe you want to watch and see how I do it, and maybe work along with me. But the thing is, the key is you have to actually be doing the problems. If you're not doing, you're not learning. So that's the biggest thing. All right, so let's go ahead and move on to our first problem of the day. And our first problem of the day, let's just zoom in a little bit. Our first problems of the day are going to be these two here. I'm going to do them one at a time. So in this case here, what I have is x plus 7 is equal to negative 4. And the way that we're going to handle this in algebra is we're actually going to try and undo the things that have been done to this variable to get this. So in other words, this x right now, to get the negative 4, it added 7, right? So you can think about the operation that's present to this variable is adding of 7, right? So since 7 is being added, I actually want to do the inverse of it, right? And in case you don't remember the inverse operations, you have 4 basic operations. You have subtraction, addition, multiplication, and division. And basically, subtraction is the opposite of addition, and multiplication is the opposite of division. So that if you wanted to undo what one of these did, you could do the other one. So in case that didn't make sense, let me go ahead and just show you with this one. Right now, this is being added. 7 is being added to this x to get to this. So if I want to undo that 7 being added, what I have to do is actually take the opposite. And we call that the inverse operation, right? Now, because this is an equality, because this is an equation, it's balanced. You could think of it like a balance beam, right? Because it's like a balance beam and I want it to stay balanced, if I take away 7 from this side, right? It's already got some stuff over here, it's got some stuff over here, and right now it's balanced. If I take away 7 from this, if I make this side lighter, I also have to do the same thing to this side here. So I have to take away 7 from this side. If I don't do that, I actually break the equation and it won't work anymore. So in this case here, what I've done is I've undone the positive 7 with the negative 7 by doing the inverse operation, and now I'm just going to simplify what I have. On this side here, this plus 7 and this negative 7 cancel out because positive 7 and negative 7 cancel out, and I end up with x is equal to negative 4 plus a negative 7. Negative 4 plus a negative 7 at that point, or negative 4 minus 7 is how you could think about it. In fact, here, let me just go ahead and write out negative 4 minus 7, right? Because I just had the negative 7 there. And so in this case here, now I have to simplify this negative 4 minus 7, and I end up with x is equal to negative 11. All right. Now, at this point, you're thinking, wow, well, that's interesting. That's pretty cool. But you know, the really cool thing about linear equations is you never have to wonder if you got it right. The way you can check to see if you got it right is you plug this negative 11 into your original equation. And what you should get is this, it should work. If it doesn't work, if it doesn't end up being equal on both sides, then yeah, you messed up, right? So in this case here, what I'm going to do is I'm going to plug in for my x into my original equation. My original equation, once again, was x plus 7 is equal to negative 4. So I'm just going to take and plug in this negative 11 here into x. So that's going to look like this. I like to do it with parentheses. Negative 11 plus 7 is equal to negative 4. And so basically that's just negative 11 plus 7. Negative 11 plus 7 is going to equal negative 4. Because I have negative 11, if you think about a number line, right? I'm at negative 11. Let's say 0 is way over here somewhere, right? 0, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? So I'm at negative 11 and I want to go plus 7. So I want to go this way 7. So that's going to be 1, 2, 3, 4, 5, 6, and 7. Right? So negative 11 plus 7 is going to be 1, 2, 3, 4. Negative 4. That makes sense? So negative 11 plus 7 is equal to negative 4. Right? And you'll notice that negative 4, I don't like that. Let me actually line up I like to line up my equal signs. Negative 4 is equal to negative 4. Now, if you think about it, negative 4 should equal negative 4. So this step, what I did here, when I substituted back in all of this, we could call that your check, okay? What you're doing in this case is you're checking to see if you're right. And I highly suggest that you do that in general. If you're curious of whether or not you got the right answer on a simple linear equation, yeah, might as well, right? You can just put it in. If it works, it works, and you know you got it right. If not, well, it didn't work. Well, then you know you need to rework it, right? So, all right, so that's that problem. Let me go ahead and do this one here. So 2x is equal to 10. So I'm going to ask you the question, what operation is currently present here that's happening to the x? And if you look at it and you think about it for a second, you have 2 next to the x. And another way you could say that is 2 groups of x, right? 2 groups of x. Well, the question is, what do you think of, what operation normally talks about groups of something? Well, subtraction doesn't talk about groups of something. It talks about taking away something. Addition talks about adding something, but it's not talking about adding groups of something. So this right here, multiplication does talk about groups. Division talks about breaking something into groups. But this one here, I have 2 groups of something. That's going to be multiplication. So that's 2 groups of x. I'm sorry, because what I'm saying, sorry, because it's 2 groups of x, what I'm saying is I could describe this as 2 times x, right? Or another way I could show that is 2 times x, right? I can show it like that. All of these are equivalent, okay? But what I'm saying is that the operation present is multiplication. Because multiplication is the operation present, what I need to do to undo that being multiplied by that x being multiplied by 2, what I need to do to undo that is actually do the inverse operation. So if multiplication is the operation present, as we saw over here, the operation that's opposite of that is division. So what I'm going to do is I'm actually going to take this 2. I'm actually going to take my original thing here. I'm just, once again, all of these are equivalent, but I'm just going to write what we saw originally when we had 2x is equal to 10, right? And I'm going to take and divide that by 2. Right? And if I do it to this side, remember, because it's an equation and these sides have to stay equal, I'm actually going to do the same to this side. So I end up with 2x over 2 is equal to 10 over 2. Well, as you know, 2 divided by 2 would be 1, so those will cancel out, right? And I have just 1, right? So I end up with 1x, which is really just the same as x, right? So I can get rid of that 1. I'll just put the x instead. X is equal to 10 over 2. Well, as you know, we can simplify 10 over 2, and 10 over 2 can become 5 because 10 divided by 2 is 5. So that tells me that x is equal to 5. Now you might be thinking, yay, we're done. But you know, you should always, once again, because linear equations, you can always just check if you're right. We're going to go ahead and put this 5 back into my original equation. I'm going to put it up there. So I'm going to put 2 times 5 is equal to 10. And if I do that, I get 10 is equal to 10. And that tells me that, yay, I got it right. Because it worked out, I got it right, right? So this right here was my check. And I always suggest, once again, that you check, okay? Hopefully this hasn't been hard. At this point, I'm trying to just do some really basic ones to just get your feet under you. And then we'll move on to some more complicated ones. So in this case here, I have y over 3 is equal to 9. Let me zoom in just a hair. Whoa, didn't want to do that. These are 2 more examples here. So this one here is y over 3 is equal to 9. So I'm asking you once again, notice we don't have x now. We have a different variable. We have the variable y. So my question to you at this point is, what is the operation that's present? And I want you to think about the operation present. And if you want to go ahead and give it a shot, it never hurts to go ahead and give this problem a shot. So go ahead and give it a shot. Alright, hopefully you paused the video and you actually gave the problem a shot. And what you have here, the operation present is division. You have y being divided by 3, right? And in this case here, because y is being divided by 3, I want to undo what's happening to that y. I want to actually do the inverse operation so I can get rid of this 3 in the denominator. So what I'm going to do is I'm going to take my y over 3, I'm just going to rewrite it here, and I'm going to actually multiply it then. Y over 3 equaling 9, sorry. And I'm actually going to multiply it times 3. And that multiplying it times 3 is going to help me get rid of this 3 in the denominator. Undo is going to help me undo what's happening to this y. Because the y is being divided, if I multiply times 3, it undoes what was done by the division of 3, right? And once again, since I multiply by 3 on this side, I have to do it also on this side. So I have y over 3 times 3, and so these 3's cancel out. And if you think about it, like 3 over 3 is 1, right? So that's kind of why they cancel out. 3 divided by 3 would be 1, right? And so I have y is equal to 9 times 3, which tells me that y is equal to 27. Now, once again, don't take my word for it. You can actually plug it in here and see. So here I have 27 divided by 3 is equal to 9. And what I've done is I just took and plugged my 27 in for the y. That's why the 27 is up here. 27 divided by 3 is equal to 9. And if I do 27 divided by 3, I get 9 is equal to 9. And what that tells me is that this is the right answer actually. This just tells me that I was successful, that my check worked, right? And I'm going to give myself a nice big check. I'm sorry, that looks like chicken scratch. Let's try that again. So check. This was my check step, right? And this just tells me, yay, I am right. So this was the work to my problem, okay? And this was my check step, right? Let's go ahead and do the next one. Once again, pause it to see if you can do it by yourself. All right, hopefully you actually did pause it to see if you could do it by yourself. In this case here, what I'm going to do is I'm going to, the operation currently present is subtraction. I have a subtraction of 3 because there's a negative 3 there, right? And so the z is being added to this negative 3 or subtracted by 3. And so what I need to do is actually add the opposite because I want to do the inverse operation to undo it. And I end up with z. These two cancel out. So on this side, all I'm left with is z. Z is equal to, what is that? That is so ugly. I'm sorry, I have to fix that. It's going to bother me. So z, there we go. Z is equal to 22 plus 3. And then, of course, I can simplify that to 25. And z is equal to 25. And that gives me, if I were to put this in the original one, I would get 25 minus 3 is equal to 22. And sure enough, 25 minus 3 is equal to 22, which equals 22. And so as you can see, I've checked it. It's been checked, right? So that's my check. My check step was starting here. And my actual work for the problem is all of this here. Okay? All right, so hopefully that wasn't too tough for you. Hopefully you're making good progress on that. Let's go ahead and do one more so that we can just see how you're doing. And so what I have here, oh, didn't want to do that. What I have here are two more equations. I have 4/5 x is equal to 20 and 3y is equal to 8. And so for this one here, you could view this as a one-step equation, or you could view it as a two-step equation. And this time, I'm actually going to choose to view it like a one-step equation. But before I do that, let me go ahead and do this one, because this one's going to be a little complicated. Let's go ahead and start this one off first. So I have 3y is equal to 8. And I know the fraction is scaring people, so let's do this one first. 3y is equal to 8. So in this case here, what's being multiplied times the y? Well, the operation present multiplication, because the 3 is being multiplied times the y. So in order to get rid of the multiplication or deal with the multiplication, I have to divide by that thing that's being multiplied times y. And so that gives me divided by 3. And I get y is equal to 8 over 3. And really, just so you know, a lot of times in algebra, we're just going to leave it. We don't mind necessarily improper fractions and things like that. So we're just going to leave it. Y is equal to 8 over 3. You could also, though, also say that y is equal to 2 and 2/3, which would be the same thing, right? And you get that by taking the 8 and breaking it up into groups of 3 to get 2 wholes and then 2/3 left over, right? That's another way of saying the exact same thing. You could also do decimals, but in algebra, more often than not, I think you're just going to see us leave it as a fraction, all right? You could see this as well, but you're not going to see just a repeating decimal as a test answer. Generally speaking, they're not going to do that to you, okay? So anyway, hopefully that made sense. Let's go on then to this one here. And by the way, if you wanted to, you could actually check this one to make sure you got it right by putting it in for y. But I'm not going to do that at the moment. I'm going to trust that you can do that by yourself. And so let's look at this here. We have 4/5 x is equal to 20. So what's scaring people a lot now is they see this 4/5 and they're not sure what to do. Well, there's actually two different ways we can tackle this. We can tackle it like a two-step equation where we actually multiply by 5 to get this out of the denominator, and then we divide by 4 to get that out of the numerator. But you know what? I'm going to do something a little different. What I have here, if you think about it as one operation, I have x being multiplied times 4/5, right? So in other words, I have the operation present is multiplication. So multiplication is my operation present, right? I'm just going to write mult so I remember. Multiplication is my operation present. Now, in order to deal with that, then I have to divide by whatever x is being multiplied by. Well, since x is being multiplied by 4/5, right? The way that you divide by a fraction, remember, is you multiply by the reciprocal. So in other words, what I have is I have 4/5 x is equal to 20. And what I want to do is I actually want to take and divide that x by the 4/5. And the reason I want to do that is because x is being multiplied times 4/5, right? So I need to get rid of that by dividing by 4/5. But if you recall correctly, when you were in 5th grade, you would have done a problem that basically said, okay, if I'm multiplying by something, right? Let's say I'm multiplying 3. I'm just going to do a blast from the past here. This is your blast from the past. Let's say I multiply 3 times 4/5, right? I'm sorry, if I divide 3 by 4/5, then what I end up getting is the way that you did this was you actually you did something called keep, change, flip. That's what you called it, but that was only one name for it. Your teacher mentioned something else, and I'm sure that you probably have forgotten it by now, but they probably tried to beat it in your head, but it just doesn't always stick. So here you have keep, change, flip. Essentially what you're doing is you're keeping the 3/1, right? The 3/1, and you're changing this to multiplication, right? And then you were flipping this to 5/4. Now, you called that keep, change, flip, but there was another name for it, and your teacher mentioned it, and you've probably forgotten it, but it was called multiplying by the reciprocal, because this 5/4 is the reciprocal of 4/5, and this division gets changed to multiplication. So what you did to divide 3 by 4/5, what we actually did was multiplied it times the reciprocal of 4/5. In other words, I flip these two over the fraction bar, and that gives me 5/4 instead of 4/5. And so whenever you want to divide by a fraction, you actually multiply times the reciprocal. So here, when I'm actually trying to divide by 4/5, the way I'm going to write that is I'm actually going to take my 4/5 x, right? And I'm actually going to multiply it by the reciprocal, which is exactly what I showed you doing here, right? But instead of having 3 here, I actually have this 4/5 x that I'm dealing with. So I'm multiplying it by the reciprocal because I want to, since I'm dividing by 4/5, I'm multiplying it by its reciprocal, which is 5/4, and that's equal to 20. Once again, I also have to multiply this by the reciprocal of 4/5, which is times 5/4, right? And so now what I have is I have this 4/5 and the 5/4 cancel out because 4 times 5 is 20 and 5 times 4 is 20. So you have 20/20, which ends up being here. Well, I'll just work it out. 20. You have 20/20x, right? Which is equal to 20 times 5, right? All divided by 4, right? And then this 20/20 is really just 1. So what I have is 1 times x, which is just x, is equal to 20 times 5 is 100 divided by 4, right? So x is equal to 25, right? Does that make sense? So hopefully that made a little bit of sense to you. Once again, I would do it by doing that step where I multiply by the reciprocal. Like I said, there's another way you can do it, right? I'm going to go ahead and just erase a couple things here. Well, no, I think I have some room. The other way that you can do it, and the way that a lot of students do it, they actually like to do it like a two-step equation, which is something we're going to learn towards the end of this video here. So in this case here, you have 4/5 x is equal to 20. And what they do is they would actually multiply times 5 on both sides, right? And those fives cancel out. I end up with 4x is equal to 100, right? And then their next step would be to divide it by 4 on both sides, right? And that also works, but that makes it a two-step problem in a way because you actually had to do 2 steps to do it. So I kind of prefer multiplying by the reciprocal. But once again, I want you to see I ended up doing the same thing. Here I multiplied the 20 times 5. Once again, here I multiplied the 20 times 5. Here I divided the 100 divided by 4. I did the same thing here, right? The only difference is here it just took me 2 steps to get rid of this 4/5 rather than 1 step. Okay, so anyway, either way you get the same answer, x equals 25, and if you plug it in, you should get that that the equation works for you. All right. So okay, so at that point, that's basic, simple one-step equations, right? They're not very difficult. You should be able to handle them on your own. So what I'm going to do is I'm actually going to move now onto multi-step linear equations. Now these multi-step linear equations are they can be a little bit more difficult. They're not terribly difficult. You just have to keep your wits about you and make sure you don't make any careless mistakes, right? So in this one here, what I have is I have 6x plus 4 is equal to 40. And I actually could do either of these first. I could, if I wanted to, divide all of these by 6, but that gives me fractions. And let's face it, if I'd start dividing 4/6 and 46, if I start using a lot of fractions, people are going to start crying. And so let's avoid the tears, okay? My tear jars is not nearby me, and so I just can't collect those tears right now. So let's go ahead instead and do this. What we're going to do is we have 6x plus 4 is equal to 40. We're actually going to try and get this term here, this variable term by itself. And the way I'm going to do that is I got to get rid of this like extra baggage here, right? So I want to get my x by itself, at least the term for the x by itself. So I'm going to take this and get rid of it. And the way I do is I look and I see the operation present is positive, right? Addition is adding 4 to it. So since that is the operation present, I'm now going to do the inverse of that. Since the inverse of addition is subtraction, I'm going to subtract by 4. And if I do it on that side, I'm going to also do it on this side here. And then I'm going to tally these up, and I end up getting 6x, once again, because these two cancel out, right? 6x is equal to 40 minus 4, okay? And at this point, I have 6x equal to 40 minus 4, right? And if you actually simplify that further, you get 36. So you get 6x is equal to 36, right? So from this point on, it's already taken me one step to get to where I am now. What I'm going to do now is actually do the next operation that's present. As you can see, x still is being multiplied times 6. That's what that means, that implied multiplication by juxtaposition. Anyway, just, in other words, since 6 is right next to it, that means 6 is multiplying x times 6. And so I want to actually, since it's being multiplied, I want to do the opposite, the inverse of that, which is going to be dividing by 6. So I'm going to do that on that side, and I'm also going to do it on this side. So these 6, if x is being multiplied by 6 and being divided by 6, then those cancel out, and I'm left with x is equal to 36 over 6, which is equal to 6. And once again, I don't have to wonder if I got this right. I can actually take and plug in my values for x. In fact, I'm going to do that up here. I'm going to put 6, and then I got the 6 here, right? I got the 6. X should be 6, so I'm going to plug it in there. Plus 4 is equal to 40. And I should get 6 times 6 is 36, plus 4 is equal to 40. 36 plus 4 is 40 is equal to 40. And so what that tells me is my check worked, right? I checked it, and it worked. That's my check. So my correct answer is x equals 6. And here's all my work to show it right here. Okay. All right, so basically, I just managed to solve that with gusto. Yeah. So anyway, that was fun. All right, let's do the next one here. I get negative 3z plus 12 is equal to 14. So in this case here, the operation that's present that's keeping me from getting to my variable term is addition of 12, right? So I need to do the inverse of the addition. I need to do the inverse of adding. So in that case, I'm going to subtract. And what am I going to subtract? Well, I don't want to leave this behind, so I need to do the exact opposite of that, which I'm going to subtract 12, right? So it can cancel out. And I'm left with negative 3z is equal to 14 minus 12. And I could actually do that 14 minus 12 in one step here. That's 14 minus 12 is 2, right? So negative 3z is equal to 2. And now my next step is I need to figure out, well, what's keeping me from getting my z alone? And as you can see, it's being multiplied times a negative 3. Because it's being multiplied times a negative 3, I need to divide by negative 3 in order to get z alone. But since I'm doing it on this side of the equation, in order to keep the equation intact and keep it from breaking, I actually need to do the same on this side. So these negative 3's cancel out. I end up with z is equal to a negative 2/3, right? Because that negative applies to the whole fraction, really. So I get z is equal to negative 2/3. And that right there is my final answer. And once again, if I wanted to, I could plug that in. Negative 3 times a negative 2/3 is going to be a positive 2, right? Positive 2 plus 12 is going to be 14. 14 is equal to 14. And so, yes, it worked, okay? So once again, that's how you would solve that multi-step linear equation. Notice we subtracted first to get rid of the positive 12, and then we divided by negative 3 to isolate the z by itself, okay? All right, so at this point, I hope you are doing pretty well at this. I think that hopefully you are actually doing the problems. Remember, if you are not doing the problems, you're just not learning. So let's go ahead and move on to the next problem here. I'm going to zoom in just a hair. And I get 5x plus 2x plus x is equal to 8. Now, at first glance, this actually looks pretty ugly, right? But here's what I want you to do. I want you to go ahead and give it a shot by yourself. See if you can't figure it out. Hopefully you actually paused it and tried it by yourself. What I have here is I have 5x, I have 2 plus 2x plus x. And so what I'm going to do is I'm going to start by what we say combining like terms. I have multiple x's. They're all to the first power, right? In other words, they don't have like a squared exponent or anything like that. So all of these I can combine. This says I have 5 groups of x. This says I have 2 groups of x. And this says I have one group of x, basically, or just x, right? So what I'm going to do is I'm going to take my 5x and my 2x, and I'm going to combine them. I'm going to have 7 groups of x plus x, or 7x plus x. And that's going to be equal to 8, right? And I should actually move that closer on that side. I don't know why I didn't. But anyway, basically what we have is 7x plus x. I'm going to put these together, and I end up getting 8x is equal to, sorry, let me move that a little closer. I get 8x is equal to 8. So at this point, I mean, I can even reason it out. I can say, well, what do I multiply times 8 to get 8, right? And as we know, that's 1, right? But I'm actually going to do it algebraically, and the way I would do it algebraically is, since x is being multiplied times 8, I need to do the inverse of that to get rid of that multiplication of 8, or to undo it. And so the way I'm going to do that is divide by 8, because 8's dividing is the opposite of multiplying. So if x is multiplied times 8 and then also divided by 8, then it's just going to leave me with x. Or to put it a different way, 8 divided by 8 is 1, so that's going to leave me with 1x, right? 1x is equal to, and if I did it on this side, I have to do it on this side as well. So 8 over 8 is equal to 8 over 8, right? And I'm just going to go ahead and write that down. I really don't need to write that down that step, but I just figured why not. 1x is really the same as x, because 1 times anything is the same thing. So I now have x is equal to 8 over 8, which is really equal to 1, because any number over itself is the same number. So I'm left with x equals 1. All right, so once again, I don't have to take my word for that, or I don't have to wonder if I got it right. I could actually plug in everything, and I'll do that right now. I'll go 5 times 1 plus 2 times 1 plus 1 is equal to 8. And if I actually do that, 5 times 1 is 5, plus 2 times 1 is 2, plus 1 should equal 8, and sure enough, 5 plus 2 is 7, plus 1 is equal to 8, and then once again, 7 plus 1 is 8, 8 is equal to 8, and since that worked, I can say my check is complete, right? But this is the actual work that I'm interested in, because this is the one that actually isolated that variable for me and told me what x is, right? This is just a check step, so I feel really good about my answer. And hopefully that worked for you. All right, here's another one. Let's try this one. I want you to try this one once again by yourself. All right, hopefully you paused the video and did try this by yourself. And what you ended up having was 3x plus 4 is equal to 9x. Now, I hope that this was a little bit of a struggle for you so that we can kind of talk about it and think about it. So what I had here is, the problem is I have x's on both sides. So you might be wondering, okay, if I pull the 4 over there, I'm still left with this 9x over here, and you're like, there's variables on both sides. I'm going to cry on the inside. Tears flooding the world. Yes, I get that. But here we go. What I'm going to do is I'm going to show you that it's actually not as scary as it looks. But what we need to do is we want to get kind of all our x's on one side, right? So what I have here is I have 3x, and over here I have 9x, and I'm going to look at which one of these is smaller. Is the 3x smaller or the 9x is smaller? And in this case, obviously we know that 3 groups of x would be smaller than 9 groups of x. So what I'm going to do is I'm actually going to take and subtract from this side 3x, because 3x is being added to the 4, so I'm going to do the opposite. Since this is a positive 3x, I'm going to subtract by 3x, right? Then I'm also going to do that on this side here, subtracting by 3x. So now I have 4 is equal to 9x minus 3x. Well, as you know, 9x minus 3x is the same as 6x, because if I have 9 groups of x and then I have subtract 3 groups of x, I'm going to end up with 6 groups of x. So I now have 4 is equal to 6x. And now the operation that is present, if I really look at it, is this is multiplication. So I'm now going to divide it by 6. If I do that on that side, I must also do it on the other side, right? These 6 over 6 cancel out and actually become 1. So that becomes 1x, which is equal to just x, right? So I now have x is equal to 4 over 6. But really that can be simplified by dividing both the top and the bottom by 2. In other words, 4 over 6, if I divide 4 by 2 and I divide 6 by 2, I end up getting 2 over 3. Or in other words, 2 over 3 is equal to x. And that right there is my final answer for this problem. Now, if I really wanted to try it out, once again, I could actually plug in 3x plus 4, and it should equal 9x. I could actually do 3 times 2/3. Sorry, that should be 2/3. Plus 4 is equal to 9 times 2/3, right? And this 3 and this 3 are going to cancel out, and I end up with 2 plus 4 is equal to 9 times 2 divided by 3, right? All I did was move that into it. So 9 times 2 over 3, which is equal to 18 over 3 is equal to 6, right? But I can simplify this 18 divided by 3 more, and that becomes 6 is equal to 18 divided by 3, which is 6, right? And I'm left with 6 equals 6. And that right there is my my solution. So x is equal, I'm sorry, that right there is my check. Since 6 equals 6, then I know I have 2/3 right as my answer. Which brings me to my next one. Here we go. 8y minus 2y plus 18. Once again, you should pause this and give it a shot. So in this case here, I have 2y on this side, I have 8y on this side. So my question is, which one do I want to move? Well, I'm going to take us back to the last problem we did very quickly and ask the question, why did we decide to move the 3x over the 9x? Well, as you can see, when I moved the 3x, I subtracted by 3x, and I subtracted by 3x, I ended up with a positive 6x on this side. And it's nice to have a positive 6x because then I don't have to multiply, I don't have to worry about any negative numbers later on in terms of negative coefficients for x, right? So generally speaking, what you want to do is take and subtract your smallest of the x terms, or your smallest of the variable terms from both sides, right? As opposed to subtracting the 9x, because then I would have gotten a negative 6x over here. And although it would work, it's just a little bit more of a pain in the bottom. So here I have two choices. I have the 8y and I have the 2y. So my question to you is, which one are we actually going to do in this case? Well, hopefully you decided to actually deal with this 2y here, and I'm going to actually do negative 2y to get rid of it because it's a positive 2y now, so the operation present that I got to deal with is really addition, so I need to actually take and subtract by 2y, and then I'm going to do the same on this side here, minus 2y, right? And I should get 18 is equal to, that's this 18 here, and these two will cancel out, right? 18 is equal to 8y minus 2y is 6y minus 2 is equal to 18, right? And at this point, it looks better than it did because now I have y's only on one side of the equation, but it still doesn't look great because what I need to do now is I actually need to take and I need to add 2 to this side, and I also need to add 2 to this side. And by doing that, I end up with 6y is equal to, these cancel out, 18 plus 2, which is 20. Now I take and I actually, I'm going to see what operation is present. If you look here, y is being multiplied times 6. Well, because y is being multiplied times 6, I actually need to do the opposite of that to undo that multiplication times 6, right? So the opposite of multiplying times 6 is dividing by 6. Now if I do that to the other side, I must also do it to the other side. And I end up with y is equal to 20 divided by 6, which is, I'm actually going to take and simplify that by dividing both the top and the bottom by 2. And I'm left with, so y is equal to 10 thirds. And at that point, if you wanted, we could turn that into a mixed number, which would be, in case you're wondering, 3 and 1/3. That would be the mixed number that becomes. But I'm just going to leave it y is equal to 10 thirds. And a lot of times you're going to find that to be the answer on the test. All right, so hopefully that's making sense to you so far. We have a few more examples and then we're going to call it for the night. But let's go ahead and try the next one. All right. So this one here, hopefully I would like for you to pause it and just see if you got it right. All right, so in this case here, I have 4x minus 3x plus 4 is equal to 20. And so what I'm going to do is I'm going to take my negative sign, and this one, you're really looking at it and you might be kind of perplexed because you might be wondering, what on earth am I supposed to do here? You might not see that there's, you might be wondering, what can I multiply? There's nothing here, there's no number here, and so this might be a little confusing to you. But what I'm going to do is I'm actually going to distribute like we've been learning to distribute, and I'm going to take and I'm going to distribute this negative, because really this is, I could rewrite this as this, -1 distributed into this 3x plus 4, right, is equal to 20. I could write it like that if I wanted, but I'm not going to. I'm actually going to just leave it like this. I mean, I did to show you, but I'm just going to work with it like this. And what I'm going to do is I'm going to distribute this negative to everything on the inside, right? So in this case here, I have 4x. I'm actually going to skip this line here because I don't want to bother with the -1 nonsense. I just want to, it's the same thing, but I just want to just do it with the negative. So I'm going to distribute the negative in. I get 4x minus 3x. And then that negative, a negative times a positive 4 is going to be a -4, so -4. So all I did was distribute it. Once again, that's negative on the inside. So I end up with 4x minus 3x minus 4 is equal to 20. Now that I've done that, I actually can start combining some like terms here. What I have here is I have my 4x minus my 3x, which is going to just be x, right? That's going to be x. I'm actually going to write that a little closer. So I'm going to have x minus 4 is equal to 20. Well, at this point now, I still have this -4 that I need to deal with. And so the way I'm going to handle that is I'm going to take and add 4 to both sides. Right? Add 4 to both sides. And I should get x, because these two cancel out, I get x is equal to 24. And that right there should be my answer. Once again, I can actually check that if I want. And with the calculator, that's super easy actually. You just type it in. You just got to make sure you get the parentheses right. I go 4 times 24 minus 3 times, 3 times 24 plus 4 is equal to 20. And this, I would actually just do this side. I wouldn't type this into the calculator. I would just do this side and see what it equals. And the 3 times 24, gives you 72. So now I have 72 plus 4, right? I have subtraction. I have 4 times 24 is 80, 96 is 96. So I now have 96 minus 72 plus 4, and the 72 plus 4 I could actually add together. I get 76. So 76, so 96 minus 76 is equal to 20, and indeed that's true. 96 minus 76 is equal to 20, and 20 is equal to 20. So my check worked. I checked it, and it worked, and it was beautiful, and I loved it. So this is the correct answer. I did this right. Okay. All right. So that's your solving for that now. I think we're doing pretty good. And I'm going to now move on to a little bit of harder problem. Let's see if you can handle it. All right, so here's your harder problem here. I have this big mama jama. So I have 13 minus 4x plus 8 is equal to 4 times x plus 3 plus 9x. Go ahead and pause the video and try it yourself. Remember, challenging problems make your brain grow. My baby girl said that, and she is right, and I love her. So, all right, so here we have 13 minus 4x plus 8 is equal to 4 times x plus 3 plus 9x. Go ahead and pause the video and try it yourself. All right, hopefully you did actually pause the video and try it yourself. This is just putting together a lot of the components that we've seen already. There's nothing particularly difficult about this problem except for there's lots of places you could make mistakes, so you do have to be careful. In this case here, what I have is I have some stuff that needs to be distributed. So let's go ahead and just go start that. I have my 13, which is going to stay the same, but my negative is going to distribute to the stuff on the inside, right? So I have negative 13 minus 4x, right? And then minus times a positive 8 is going to be minus 8, right? And that's all going to equal 4. And I could actually take and distribute this 4 as well. I'm just going to do it all in this step here. You could actually split it into multiple steps if you want, but I'm just going to do it. It's on the different side anyway. And I got 4x plus 12 plus 9x. Once again, I got the 4 times x is 4x. 4 times 3 is 12, which is how I got that. And so basically what I have here is now a lot of different terms, right? And I'm actually going to look and say which one is my smallest. Well, you know what? I'm actually going to combine like terms first. Because if I combine like terms, it's just I have just less to have to deal with. So I'm going to go ahead and combine the like terms here. I have a 13, and I have a minus 8, and I have a negative 4x. So I'm actually going to combine my 13 and my negative 8. And 13 minus 8 is, my brain just stopped. 13 minus 8 is 5, right? So I have 5 now minus 4x is equal to 4x plus 12 plus 9x. So I'm going to combine these two, this 4x and this 9x here, and I'm going to get 13x is equal to 13x, and I'm going to add the 12 here to that. And so now what I have is I've simplified it basically a lot. First step I did once again was distributing, right? After I distributed, I just combined some like terms just to make less to work with, right? So now I have this term here and I have this term here. So I'm going to ask myself the question, which one is my smallest x term, right? And I'm doing my smallest x term because I want to know even what side my x is going to be on before I start moving around constants, right? So my smallest x term is this negative term because negative 4 is much smaller than 13. So in this case here, I'm going to add 4x. I'm doing the opposite of it. So since it's subtraction of 4x, I'm going to add 4x. If I do it to that side, I must also do it to this side, right? And so these cancel out now, and I have 5 is equal to 17x plus 12. And I'm almost done, but I'm not quite done. I actually have a few more steps to do. So in this case here, I'm looking at what is keeping me from getting this variable term of x alone. And so what's keeping me is this baggage here. So what I need to do is I actually need to subtract by 12. Since I'm being added by 12, I need to subtract by 12 here. Okay. And I get, these cancel out, and I get 17x is equal to 5 minus 12, which is negative 7, right? So I get negative 7 is equal to 17x. And at this point, there's only one operation left. The operation that's being left that I need to deal with the x is 17 multiplied times x, and I deal with that by dividing both sides by 17. And I end up with getting negative 7 over 17. That's just ugly, but that's just how it is. That's just the simplest the fraction could go is equal to x. That right there is my final answer. And although I could put that in to see if I got that right, without a calculator, I don't want to put that in. That's annoying. But with the calculator, that would be super easy to put in. You could actually just take and start plugging in this for any place you see x. It wouldn't be super easy because you do have to be careful that you don't accidentally, I always substitute with parentheses to make sure that I don't accidentally mess up this negative at all. But anyway, when you're done, what you should get is that this side is equal to that side. And so anyway, I end up with x is equal to negative 7 over 17. So hopefully that's what you got. If that's not what you got, hopefully you can figure out where you went wrong. I think I have one more problem for the evening. This is the big mama jama. Let's see if you can handle it. This problem here, the beast. All right. So this one here, the reason this is the beast is not only do you have parentheses that you got to distribute, but you have parentheses inside of parentheses. And so I know people are crying on the inside. Yeah, that's awesome. All right. Let's see if we can get those tears to the outside. The way that we do that is by actually trying the problem here. And what I have is I have this 9 times 2 minus 3x plus 12. And what I'm going to do is I'm actually going to start with the innermost set of parentheses. I'm actually going to distribute this to the innermost set of parentheses first, right? So I have the 7 that I'm going to distribute to this x, and this is minus 4. So let me just rewrite a few things here. I have 3 times 4x plus, and here I'm going to do my distributing. So the 7 is going to be distributed to the x and to the negative 4. So I have plus 7x, and then 7 times a negative 4 is a minus 28, right? Is equal to 9 times 2, and once again I can also do the distributing on this side. I got 9 times 2 is 18, and 9 times a negative 3 is minus 27x, right? Okay, and that gives me plus 12. All right, so what I have still some stuff that needs to get distributed on this side, so I'm going to go ahead and do that really quickly. I'm going to take well, before I do that, actually, I want to combine some like terms, because then I don't have to distribute as much. So I'm going to take this 4x plus the 7x, and that's going to be 11x minus 28, right? 11x minus 28. I have 3 times that is equal to, in this case here I have 18 plus 12, which is equal to, once again combining like terms, right? 18 plus 12 is equal to 30. So I have 30 minus 27x. And I can take now and finish distributing on this side. So I'm going to distribute the 3 into the 11x and into the negative 28. So I have 3 times 11 is 33x. And then I have 3 times a negative 28. And I'm actually not sure what that is off the top of my head. Although I could do it. Is use calculators when you have them. So I have 28, negative 28 times 3 should equal a negative 84. So I got 33x minus 84. Let me see if I can rewrite that so it's just a little more clear. Minus 84 is equal to 30 minus 27x. And what I need to do now is I have two different x's. I have a 33x and I have a negative 27x. And I need to ask myself which one of those is smaller. And the reason I want to know which one is smaller is I want to keep my x as a positive. So this is the smaller x. It's negative 27x, right? So I'm actually going to take and work with this one. I'm going to get a positive 27x to cancel out the negative 27x on this side. And that means I'm going to add on this side 27x, right? So that's going to give me 60x minus 84 is equal to 30, because these two here cancel out, right? So at this point, I need to still get this constant over to this side. So I'm going to take and add 84 to both sides. That cancels these two out. I'm going to add 84 to this side too, right? And I end up with 8, 9, 10, 11, 114 is equal to 60x, right? And I am almost done. Hopefully you were able to do the Big Mama Jama by yourself. But if you weren't, I hope you figure out where you went wrong in the process. So in this case, I'm going to divide by 60. And divide this also by 60 because currently x is being multiplied times 60, so I want those to cancel out. And I end up with x is equal to half of 114 would be 67, I believe. Is that right? No, that's not. Yep. No. Hold on a sec. 57 actually. So that's going to be 57. What I did is I divided the top and the bottom by 2. You know what? Let me not guess about that, but I'm pretty sure it's 57. 114 divided by 2 is equal to 57. So I have 57 over, I know 60 divided by 2 is 30. 57 over 30. And that right there is my final answer, I believe. I don't think this simplifies anymore. This is a prime number. So yep, that's my final answer. X is equal to 57 over 30. If I wanted to actually simplify that to a mixed number, it would be equal to 1 and 27 30ths, right? And actually that one there I could actually take and simplify. That would be 9 over 10. So 1 and 9/10, I believe, is what that would be. Okay. But basically, what you have here is you've been able to learn what you've learned in this video is you can take and you can actually solve for one variable if it's just a simple. You're solving for one variable. You're not solving in terms of another variable or anything but you're able to solve one variable, nothing squared or anything like that. So that's just basically solving a basic linear equation, right? And hopefully, just to bring you back from the beginning, I just want to see, look at how far you've come. When you started off as a wee little lad or lassie, you as a little boy or girl, you were able to do it with something that looked like this, and then it got more complicated, right? And before you knew it, it started to look like this, where you had stuff being multiplied and divided. Then pretty soon you had further stuff with fractions even, which just scared you, but you were still able to do it. Oh. And eventually you moved on to multi-step stuff, which is what we're doing now. And the thing is, if you can get good at these multi-step equations, a lot of it's going to just fall into place for you. So definitely get good at manipulating and solving for x, and you're going to be just fine, all right? So I hope you had a great time. I hope you learned a lot this session, and be looking out for other videos where I try and show you some other cool stuff and tips and tricks. And I hope you're having a great day. And once again, I just want to applaud you in taking that step in your learning where you're just like, I am awesome because I can learn on my own. So I'm really proud of you for doing that. If that's you tonight, keep up the great work. Keep plugging along, keep chugging along, and we look forward to more great and exciting math with you in the future. Have a wonderful, wonderful night.